All right. Welcome, everyone, to episode 59 of Accents on Trial. I am your co-host, Cease to Know. Mike will be joining us again in the near future. Hopefully later this weekend he'll be able to come back on. Still getting adjusted to new work schedule and all of that. Just a quick reminder that this Friday at 8 p.m. Eastern time, I'll be co-hosting Truth Wanted, uh, which I'm kind of excited for. It'll be my first call-in show that I've done, and I'm curious to see how that goes. But for today, we have a recurring guest, Professor David, one of my favorite guests that we've had so far, and also Professor Chandra Singh, I think is how you pronounce his name. And we're going to be discussing physics, causality, presentism, and they have a couple of PowerPoints and that they will show. I'm not as good. Thank you, Ryan. Good to see you in the comment section. I'm not as very good with the tech side of this, so I'm still learning how to share files and share screen and all that. So bear with me as I figure out how to maneuver and navigate this controls here. It's a little bit weird. I've never been good at that kind of stuff, but I'll bring in my guest here. Here we go. Hey guys, thanks for joining.
Hello.
Good. Yeah, I'm just trying to figure out how to get this to work here. So I guess first of all, if you guys can give a little bit of a introduction about yourselves. I mean, I know David has been here a few times already, but just for anybody new that's listening, tell us a little bit about what it is you do and why you're here today.
Chandra, you want to go first?
Yeah, sure. Okay. Thanks, for this opportunity. Hello everyone. My name is Chandra Singh, and at present I'm a faculty member in China. So I'm working at Yunnan University, which is basically located in the southwest of China. So my activities are mainly related to research work, namely the black hole astrophysics. So it is something related to how things fall onto the black hole and how some things escape out. So this is all I have been doing using theoretical as well as simulation works. And today I would like to talk about black hole in context of presentism. So let's see how the discussion goes. Thanks.
Sounds good. David?
And I'm also a physics professor, and I've been on the show a number of times. I also study black holes, and Chandra and I collaborate a lot. So, we're not philosophers, but we're interested in these things. So we can only take the conversation so far.
And so the main topic we'll be discussing something called presentism. How would you define that?
Presentism is just the idea that everything that's real is in the present.
In the present.
Yeah. So the past isn't real. It happened, but it's not currently something that exists, and the future obviously hasn't happened according to that view, and so that's definitely not real. And so it's the common sense view of space and time, essentially.
Right. So the past is gone, the future is yet to come.
Right.
The present also.
Right. And in light of relativity, I would say that this idea basically fails at the most superficial level when you look at relativity, and we'll talk about this. And I'll try to describe that a little bit. Sure. But some people have made objections to the criticisms of presentism from this sort of superficial perspective. And by that I mean just sort of the half of the theory of relativity or special relativity. And then I think Chandra is going to go into some of the what presentism, how presentism I think falls apart completely when you look at the general theory.
Okay, that sounds great to me. So let me share. I'm gonna go right into the PowerPoint.
Sure.
Okay. So how do I do this? Can everyone see this okay?
I'm seeing it fine, yeah. Chandra, can you see it?
Yeah, of course. Yeah.
Okay.
All right, go ahead, David.
So
Just tell me when to click forward.
go ahead. Go to the next slide. Oh, there we go. Okay, so what I want to try to describe here is this extremely powerful tool in understanding the ideas of relativity. It's called a space-time diagram, and there's a lot of intuition that we have about this kind of object. And so I want to sort of build on that intuition, and then we can sort of leap into the really strange, almost absurd conclusions. So what we're going to do is basically slice space and time up, and we're going to start with this intuitive notion that we have, right? So here I made a little cutouts of you and J Mike. Pity J Mike is not hosting
like
tonight.
I know.
But so you're looking at, so you guys are living in a one-dimensional universe here, and right on the screen, J Mike is on the left. You know, he's far away that way on the left, and you are on the right, and there's some space in between the two of you. Right, you live in different places, and so you're on this horizontal axis, right? So if you move horizontally, you're at different locations in space, but along that red dotted line, that constitutes one moment in time. Right? So time passes upwards. So if you live uninteresting lives, then you just move upwards on this diagram, right? So you stay at your location, there you are during the show, you're just moving upwards on this diagram. And so there's another slice of space at a different moment in time, and you guys are still at the same location in space. So your path through space-time is just a vertical line. It's not very interesting. Okay, so that's the idea, and we're going to impose on the structure. This is where the ideas come from. We're going to impose that all observers, regardless of how you move. So I'm going to have J Mike move towards you in a little bit, and then we'll see that for him to also measure light to be moving at the same speed as you would measure it, there are consequences on the space-time diagram, which is that he no longer slices space and time in the way that the both of you are doing right now. So right. So maybe the last thing that I could say about this slide is that, I have it labeled T1 on the bottom, right? That's some moment in time, and both of you agree that the figure on the lower right is and the figure and J Mike on the lower left. Those are both of you agree that that's happening at some moment in time, and then both of you agree later that those two upper figures are simultaneous. They're happening at the same time. Okay, so now we can go to the next slide. Okay, so here we have J Mike is traveling towards you at this point. So, right, we have the lowest slide. We have J Mike at the greatest distance from you, and then he is getting closer. So, from your perspective, we're just looking at horizontal slices. So there are 3 slices, and in each of these slices, J Mike is a little bit closer to you, and I haven't drawn the 2 lowest horizontal slices, which from your perspective sees, right? The lowest figure is J Mike getting into his vehicle, getting into his car, right? That's happening at the same time that you start the show. So there you are, the lowest picture of you. That's you started the show, and from your perspective, J Mike is just getting into his car at that moment, and then there's a moment when you're sort of halfway through the show, the second figure, and J Mike is is halfway through his trip, and then there's the latest moment, and so you're still slicing all the events that are occurring horizontally. But notice that your time, the way your time is passing, is just the vertical axis. So the way you travel in this diagram determines your time axis. So the first thing to notice is that J. Mike, he's traveling on a diagonal line. So for J. Mike, his time axis is tilted with respect to yours. That's that black dashed line that's tilted. So you can figure out what J. Mike considers to be all the things that are happening at the same time. They're no longer the same as you. So this is an issue of principle. J. Mike slices space-time differently. He's no longer slicing. His slices of all the things that are happening at a given moment in time are not horizontal the way they are for you. They're tilted, right? This is how you can, there's mathematics behind this, but this is how you ensure that the speed of light is the same from both perspectives.
So what does it mean? Like, what does slicing space-time, or what does a tilt change in terms of?
Right, you have no problem, right? Your common sense intuition of the world, you have no problem thinking about or imagining, this moment in time right now, right? I'm here, I'm somewhere in space. Chandra's somewhere in space on the other side of the world. You're somewhere, right? You ask that question, I'm about to reply to that. Chandra's listening. All of these things are happening at a certain moment in time. Right? You don't have a problem with that. So that's your slicing of space-time, right?
Okay.
Time is passing and different things are happening.
Right.
But as an issue of principle, right? So your intuition is that that's true regardless of how anyone's moving.
Right.
But that can't be true because the speed of light is always the speed of light. And so this is how you describe this. And you can do this mathematically, but it's easier to think of this in terms of space-time diagrams. That's why this thing is so powerful. It's kind of hard to describe this in 20 minutes, but we'll get some sense of this. Basically, Mike, the things that Mike considers as a matter of principle to be happening at the same time are along that tilted red dashed line.
Now, does that mean that in reality, the time is passing differently for the both of us?
That's right. Time passes differently.
Okay.
Right.
Okay.
So we can go to the next slide. So now we're going to play around with this idea of different slicings through space-time and see what kinds of things follow from this. Right. So the idea of an absolute present that goes out the window. So here's one of the characters in your shows, who's I'm imagining appearing in the chat and starts lecturing everyone on causation. And so that's an event. And from Cesa's perspective, right, that event is happening at the same time as J. Mike is halfway through the trip. So the second image of J. Mike, right, because we're talking about a slice that's horizontal. You consider you and the MM both consider J. Mike, the second J. Mike, to be part of the events that are happening at that moment in time.
Right.
But J. Mike doesn't agree with this. So J. Mike slices space as a matter of principle along that red diagonal line. And so notice that if we look at the red diagonal lines that have the same tilt, and we go through the MM, right, the magician who just came in, we don't get you, Cease. You don't get the second version of you on that slice.
Right.
So J. Mike, in fact, considers that second figure of you to happen. Right. Say you, I don't know, you look at your watch there. J. Mike considers that event to have happened before the MM enters the chat. That's just a matter of principle because now the slicing of what's happening at the same time is tilted because of the way J. Mike is moving. And so it's no longer true, as a matter of principle, necessarily that these two events are simultaneous.
Right.
And there's no violation of cause and effect. So now I'm going to bring in a cause and effect kind of relationship to sort of get at this and get a sense of how, from all perspectives, cause and effect is not violated.
Does this mean that there is no actual objective measure of time, that it's all subjective?
yes, so space and time are no longer absolute. And so there are times. So not only are measurements of time and space different, the idea of what is happening right now depends on the observer, depends on your motion. If I'm moving with respect to you, even at very slow speeds, and so we'll see this, even at very slow speeds, I completely disagree with you about things that you consider in the very distant future and in the very distant past. I can consider them to be part of the present, and that's an issue of principle. So maybe we should continue. Oh, sorry, there it is. Okay, so the next event there is cease. Right, so the MM makes a criticism, and of course it takes some time for that signal to, you have to type it, you have to enter it. It takes some time. Then you cease have to absorb the message, and then there you are, thoroughly convinced by the criticism on causation. And so you can notice from your perspective, right, because you're slicing space and time horizontally, that you indeed understand the message after the MM has sent the criticism. There's a cause and effect relationship there, right? So you can sort of see that. Your understanding comes in later. Now we look at this from the perspective of J-Mike. J-Mike slices things diagonally. So when we look at that diagonal tilt and we go through the MM, you understanding the message from the MM, that's still in the future, even from J-Mike's perspective. But he doesn't agree on the time difference that has passed. Right, so the cause and effect relationship is saved. It's still instantiated in this case, but the difference is in time now. There's no agreement about that. So maybe we can go to the next one. So I guess what did I do here? Oh, so I'm pointing out what it is that you agree with, right? You and the MM both are slicing time horizontally. So you agree that all of those things that are on your slice, the horizontal slice, are happening at the same time. So I sort of already went through this, but J-Mike doesn't agree with this. These are issues of principle. These aren't points of confusion between you.
Right.
Okay. So let's move on to. And so the point here is that everyone is correct. So there's the slice of simultaneity going through the MM, and notice that from your perspective, what's happening at the moment the MM puts in the criticism is your second image. But J-Mike doesn't agree with that. J-Mike thinks that a later event is happening at the same time as that, and everyone's correct. There's no problem there. You're not violating cause and effect.
And I don't think you're violating logic either, because
you're not violating anything like that,
right? Because it's different from different perspectives altogether.
I mean, the logic is what gets you to statements like cause and effect can't be cause and effect relationships can't be flipped, right? You can flip certain things, but they're not cause and effect relationships, as we'll see.
Right.
So. Okay, so let's extend this. Let's move out and look at things that are further away, and you'll get some very interesting things to emerge from this. So now we're going back. So from the perspective of cease and the MM, right? You guys slice space and time horizontally, and so if we go down, further down, we're going into the past, right?
Mm-hmm.
From your perspective, and so we imagine many slices or many horizontal slices, and we take this alien further and further down. That's in your deep past.
Right.
Okay, so sorry.
But it would be in the future for the alien.
No, I'm not sure what that means. Right. So the alien is making a statement here. So that's an event in space-time.
Right.
And we're looking at that from different perspectives. So I didn't actually draw a slice for you and the MM, but if I drew a slice, it would be a horizontal slice. And the alien is complaining about not being able to join axioms on trial, when from your perspective, axiom on trial doesn't even exist. I'm playing around with things a little bit, so I mean that's a cause and effect relationship. But the point is, the alien who's very far away is in your deep past. But J. Mike slices space-time as a matter of principle in a different way. And so that alien, whatever the alien is doing, which from your perspective happened 10 million years ago, J. Mike considers it happening right now. Because whatever that alien is doing, of course, the alien's not talking about accidents on trial, obviously.
Right. That's some crazy. It sounds like science fiction.
Sounds like science fiction.
Holy shit. Okay.
But there's no. Chandra, sorry.
I would like to add that means in general it can appear like fantasy, but it is about the scientific intuition, so that we have to take into account. So yeah,
of course.
Right, there's all mathematics behind it. What's really powerful about space-time diagrams is that they allow you to get at the strange or the weirdness here without having to do complicated calculations. So they're really worth the work. Of course, we're not going to be able to do this in 30 minutes, but we're getting some sense of it. So maybe go to the next slide. Right, so we're disagreeing about. It's a very strange kind of disagreement, and I'm claiming that from the perspective of the theory, all of these things are true. It's true from J. Mike's perspective that that alien that from your perspective lived 10 million years ago is whatever that event is happening right now. And now I'm going in the other direction, all the way on the right in this one-dimensional universe, far away on the right, and much later in time from Cease's perspective. Right, Cease slices space and time horizontally into slices of simultaneity that are horizontal. And so, if I take that event, go very far up and to the right, then it's happening, 10 million years into the future from Cease's perspective. Right, it's up here, and that's in the deep future from Cease's perspective. But J. Mike moving at, 60 miles an hour, slices space and time differently. That event is happening at the same time as that other event that you consider in the deep past. Everyone's correct, and you're not violating cause and effect relationships.
Right.
So, go ahead. Okay, so now I'm bringing in another observer. Right. So this is someone who's moving faster than J. Mike and is catching up to J. Mike, and so we have a different slicing. And so the tilt of all the events that are happening at the same time is even more tilted compared to J. Mike. And so if you go to the next slide, what we can do is to flip the order of events. Right. The weird thing about J. Mike's slicing of space and time is that two events, that one happened in the deep past and one in the deep future from your perspective, happen at the same time from J. Mike's perspective. But here's a different observer that's moving differently. And from this observer's perspective, the order of events, the one that you consider in the deep future and the one that you consider in the deep past, happen in the opposite order. Right, because the tilt is such that you get, if you look at the way space and time is tilted horizontally, you get first to the aliens populating some galaxy, and then you get later to the alien on the lower left.
Right.
And so that's in the future from that observer's perspective, and everyone is correct. As a matter of principle, this is what you get if the speed of light is the same for everyone. Unless you want to reinterpret things, and we can talk about that, but.
Right.
Let's finish this up. And so here are sort of my conclusions, right? It's possible to slice space and time up in this way. This is what the theory of special relativity tells us. And so, what do you mean when you say what's real is the present? There are all so many different presents. So they're all equally real from the perspective of the theory.
Right.
And so presentism basically has to fail. Then I sort of make a prediction here because I compare this to other counterintuitive ideas.
So you say here, it is possible to slice space and time in such a way that what one observer considers events in the distant past or distant future, another considers to be part of the present. It is also possible for one observer to consider an event as occurring in the distant past and the event occurring in the distant future, while another observer holds that sequence to be reversed. Presentism considers events to be classified uniquely as past, present, or future, relativity requires that such qualifications are observer dependent. Presentism has failed for over a century now. Prediction: if history is an indication, presentism will continue to be thought of as a viable idea for tens of thousands of years.
Right. So yeah. What am I getting at there? I'm just comparing to things like the idea that the Earth is a sphere and it rotates around the sun. The evidence for that kind of thing was around, long ago,
Right.
2,000 years ago, and it took, still it took 2,000 years for people to accept it, and we're still not there yet. And that's because it's counterintuitive. You can imagine the people who held to the geocentric theory, in the 1300s, you go into those experts and say, well, I don't understand what's going on with this theory. You have to reset the clock, and imagine them saying things like, well, what does it mean to reset? Why is that a problem? And making all sorts of excuses, because it was really counterintuitive to imagine that it's the Earth that's going around the sun. And this is a much more counterintuitive idea. And so I think the presentism has failed. And some people we can talk about this, and Chandra talks about general relativity, but I think that's really enough to say that presentism has failed.
But it's definitely something that's hard to, because I think the PowerPoint definitely helps, but it's definitely hard to wrap your mind around how the sequence of events could change depending on the observer. Like it seems like almost like a violation of reality. Like
I would say that it's just, I don't know, Chandra, what you would say, but I think it's just clashing with our intuition. I don't think we realize that our intuition is that first image, which is that everybody agrees that space is, that moments of simultaneity was true at some moment in time. There are these horizontal slices. We have a notion in our head that there is a matter of fact as to what's happening everywhere in the universe at this moment in time.
Right.
And also, I would like to add that when you think about time, it is the clock that you are carrying. Yes. So whoever is the observer, and suppose you are carrying a clock and I am carrying a clock, so our clocks are independent. Means we can measure time in our own way. It is not necessarily the same. So if you are at rest, your clock will measure time in certain way, and with respect to you, another person who is moving will measure the clock time in different way. So you will have a relative time in a way you can think about. So where for some like suppose there are two, like there is a famous paradoxes, like there is a twin brothers, and one brother goes on a flight with a large speed, like maybe let us imagine close to speed of light. And when the brother returns back, the brother who was traveling appears to be younger than the brother who was not traveling. So in a way, the speed causes the change in time also, like how the observer is traveling in that sense. So,
yeah, I think I think both of you are making a good point, which is the intuition that we have is that time is just the same for everybody, and in reality, it's hi Katie, thanks for stopping by. The reality is that it's far more subjective. Like that's not how it actually operates. And
well, the reality is, according to the theory of relativity, for which there's enormous experimental support, there's no such thing as the time. There are times, and that's very counterintuitive.
And while on one hand, obviously, our intuitions seem to want to kind of fight against that, we should ask ourselves, like, why should it be the case that our intuition should match the way that things actually are?
Actually, right. We should predict that our intuitions should not match.
Right. I think it's far more reasonable to kind of be more humble about sort of the distance between sort of the ontology of the way that things actually are and our perception of it. So yeah, I think it's definitely.
And also we can say that time is something like a local property, not the global one. It is just
Right.
a local property.
Okay, so Chandra, you want to
Yeah, we can. I can discuss few things about.
let me see, just one sec. Share screen.
So maybe I should just point out that before Chandra starts here, maybe I should point out that people aren't willing to abandon presentism just on the basis of the arguments that I made. They look at that and they'll say things like, well, all observers that you showed, right, that I showed, right, C, CMM, J-Mike, and the man with the proof, they're all slicing space-time in different ways, but they can all slice all of space-time into moments, they're all different moments, of simultaneity, slices of simultaneity.
Right.
They can
Right.
slice all of space-time in that way. And so that idea...
Well, hold on. Let me just
Sorry.
clarify. Is that suggesting that there is some kind of other overarching space-time? I'm not sure I understand how they could say that.
Well, it's just a matter of fact that I just tilted the spatial axes for these different observers. And so there was a notion there of all of the events in the universe at different moments, at a specific moment in time. So you could every observer could say, all of these things are happening at the same time. The aliens, the galaxy, whatever. And all of these things are happening at the same time. J-Mike, C here,
Right.
the MM there, right? So everybody has a notion of all the things that are happening at a given moment of time. That's an ideal world, because this is the world of special relativity, where we haven't talked about the effects on space and time of having matter and energy in the universe.
Right.
And so what Chandra is moving towards is a more realistic world in the sense that the real world has stuff in it. There are planets, there are galaxies, there are stars, and this stuff, according to the theory, changes space and time. So you can ask the question again, is there a notion of everything that's happening at this moment in time? And here are the kinds of things that you'll get. And that's what Chandra will describe.
You guys can see the screen, right?
Yep.
Yeah.
Okay.
Yeah. So here, what you can see is a basic idea of space-time in relativistic physics. So what you can see here is something like a light cone. It is basically called a light cone. So what happens is, for any particle in following certain trajectory, there is some kind of past and a present and a future. So according to our common intuition, maybe we will think that the space and time may be flat. But usually in relativistic physics, it happens that you don't have freedom to move around in whatever sense you want. You have to be confined in this kind of cone-like structure where your future trajectory has to be confined within this cone. Here, what you can see in the vertical axis is the time, and in the horizontal is the space.
Right.
So, for example, let us imagine about the light. The trajectory of light is supposed to be along the surface of this cone. Okay, so this is basically the 45-degree angle, you can imagine, where means the trajectory makes a 45-degree angle with respect to time and space. So in a way, the relativistic physics doesn't allow the propagation to be greater than the speed of light. So if you move away from this cone, that means you are exceeding the speed of light. So in the region outside this cone, actually the effect will be before the cause. Yes. While in general the effect should follow the cause. So in order for the effect to follow the cause, you need to confine yourself in this cone according to relativistic physics. Okay. So this is how the trajectory should be, and in general how it should be confined in this region.
Okay. Do you want me to move down to the next slide?
Yeah. So, do you want to highlight or ask anything about it, about this light cone?
Can I just make a contact
Yeah.
with what I said
Yes.
before?
Yes. Yes.
My alien that's complaining about not being able to access axioms, and the aliens that are populating the galaxy, they are far away from each other in space and, from your perspective, in time, and they are outside of Chandra's light cone. And so because of that, you can slice space and time such that which one happens first depends on how the observer is moving. But those events are not within a light cone, so you were able to flip which one happens first, which one happens later. It's completely arbitrary. It depends on how you're moving through space and time, but you're not violating causality. You and the communicating, that's a cause and effect relationship. You and the are within a light cone. So if you draw a light cone at the you understanding what he said, you are inside of the light cone.
Right.
You can't flip that cause and effect relationship.
So, and also I would like to point out that this discussion that I am trying to present is based on this paper by Romero and Perez. It is an article that was published in European Journal of Philosophical Society in 2014, and they basically wanted to present the context of presentism and the black holes. So I'm just all discussions are based on that work, and it is an interesting work, and maybe if people wants to know more, maybe some mathematics and some more perspectives, then they can
It's actually
see
that Argentinian group that I talked to you about.
Yeah. So this is actually Gustavo Romero is one of the quite senior guy working on black hole astrophysics, and actually he wrote a book also. It is called Black Hole Astrophysics. So here you can see what you can call as a presentist friendly space-time. So here you have a space and which is moving in horizontal direction along as the time proceeds. Okay, so this is just a convenient way to somehow accommodate this idea of presentist with the relativistic idea, but usually it does not work out much. It is just a way of representation. So let us move to another slide. So what I want to focus here is some kind of mysterious object that is called black hole. And when we talk about black hole, it is something you can imagine the end product of in the life of a star. So usually when a star is living its life, then there is some kind of fusion process that is happening inside the star, and this fusion process leads to some kind of radiation generation, and then the pressure related with this radiation in the star is able to keep it in equilibrium so that it is not going to collapse. Okay, so the radiation pressure is always going to act against the gravity, which may lead to collapse of the star. However, for example, in case of our sun also, it will happen like maybe, if I remember correctly, maybe after 5 billion years or something. So because our sun has already lived its half of its life, but I would like to point out that there are different kinds of end state of a star. So we call it like white dwarf. So basically, our sun is likely to become a white dwarf in far future, and there are other objects like neutron star, and also another kind is the black hole. So usually the stars which are having masses something in order of 25 solar masses. I mean to say the mass of the star is supposed to be 25 times the mass of the sun or more. Then when such kind of stars exhaust its fuel and collapse, then they are likely to make a black hole. So black hole, if you make a vertical cross section of I think you can say a horizontal cross section of space time around black hole, you will see this kind of structure. But of course, you cannot see black hole because it is it is supposed to not radiate. Yes. So in our work, I want to mention that when we try to study black holes, we are not trying to understand something from inside the black hole. It is everything that happens around the black hole. So it is a black hole, you can imagine, is something similar to a ghost inside a dark room. Okay, so the ghost will play all these actions outside the room, and you will never see the ghost. Yes. So in the same way, so black hole is
I like that
something similar.
analogy.
Yeah. So it is like something like unseen force for some people. But yeah. So what happens if you look at the structure of the black hole? Let me remain in this slide. So you have something called event horizon. So when you think about event horizon, it is nothing like a surface. It is something like a hypothetical surface, like in a hypothetical sense. So when you see some rocket leaving the Earth's surface, it is supposed to have certain velocity so that it can escape the gravitational pull, yes, of the Earth. Similarly, when in case of black hole, this event horizon represents a surface from which not even light can escape. Actually, the escape velocity of this kind of surface is the speed of light. So I mean to say that you need to have at least the speed of light to escape from this kind of surface. So anything happens inside this event horizon is causally disconnected from rest of the world. Rest of the universe, I would say. Okay. So when here you can see what we call the Schwarzschild radius. It is something named after in honor of Schwarzschild, who proposed the solution of Einstein equation. When we try, and that is it is a radius which represents the event horizon radius of a non-rotating black hole. So if you want to imagine how big it will be, then if you think that there is a black hole of suppose 3 times the mass of the sun. Okay. Usually black holes are found in the mass of the black hole is at least three times the solar mass or more. Actually, it goes up to billions of solar mass. Like for example, in the center of our galaxy, there is a black hole of few million solar mass, while in other galaxies you can find black holes of several billion solar mass. So yeah, so this is so here if you can if you want to imagine the size of this event horizon, then if there is a black hole of 3 solar mass, the size of this event horizon is supposed to be only 9 kilometers. Okay, so it is quite a small. So what I mean to say that the mass, the mass which is 3 times the solar mass is contained within a radius of 9 kilometers. Yes, and also this mass is concentrated in a singularity. Actually, this is confined by the event horizon, but it is actually concentrated in the quite small region that is like almost like singularity in the center. So this is how black hole structure is, and in astrophysics we studied something that has to do with everything that has to do with the external activities of this black hole. Okay, how matter goes around and how things come out. Okay, please go to next slide. So here, what is being shown is how this light cone behaves. Okay, so here this light cone represents basically the present, future, past. So here you can see on the left side is the exterior region, and this vertical line represents the event horizon of black holes. And then on the right side there is the interior part of the black hole. So what is happening is you can see this light cone as it is approaching the event horizon of the black hole. This light cone is shrinking. Okay, and then as soon as it enters the horizon, it is flipping the side. Okay, that means everything is going not as expected. Like as you'll think that okay, space and time should behave in a more means proper like well-behaved manner, but it is going to have deform its structure and also flip. So actually, when we talk about the interior of the event horizon, then we say that actually the space and time is actually reversing their role. Okay, here you can see on the left side, the space is in the horizontal direction and the time is in the vertical direction. While inside the event horizon, now the time is in the horizontal direction and space is in the vertical direction.
Chandra, can I make
So,
a contact
yeah,
with what I
yeah,
was
yeah,
saying
sure,
before with this
sure,
slide?
sure, sure.
So, as Chandra said, one of the things that makes this so weird is that if I drew these light cones on my space-time diagrams, they would all be tilting exactly the same way. It would be the same everywhere. At any point in space-time, I can make these cones, and they would all be pointing in exactly the same way. But what the black hole is doing is changing the way these things tilt. And so the idea of thinking of all of space at some moment in time, that's starting to look kind of weird here as a result of that.
Right.
Yeah. So yeah, and then obviously at the end of this trajectory, you are going to encounter the singularity, and about which we don't have any idea how the matter will behave after it enters the singularity. And also, I would like to point out that if you want to really, if the photons, if the light, even if they want to escape from inside this event horizon, it needs infinite amount of energy. So there is no possibility that light can escape from inside this event horizon, and also there is no possibility of communication with the things from inside the event horizon. So in a way, like for example, I can say that if you have an external observer who is looking at his friend who is falling onto the black hole, then that external observer will never see his friend crossing the event horizon. Okay, because the last light signal that can reach this external observer will be coming from the event horizon, because after that the light is not going to escape. So for the external observer, his friend never crossed the event horizon, while his friend already crossed the event horizon and reached the singularity. But for him, he will always be hovering around the event horizon. So in a way, their time is different. Yes. So for the external observer, his friend is always there for him around the event horizon. But for his friend is already crossed and disappeared, and he never knows. Okay.
Right.
So this is how weird the black hole is. And also, I would like to mention there is a common misconception that black hole is going to suck in everything, like whatever goes to, or it is going to pull everything from around. I would like to mention that if you think in terms of gravity, the gravity of black hole is same as a normal star. Okay, if there is a black hole of 3 solar mass, the gravitational pull exerted by that black hole is same as that of star having 3 solar mass. It is nothing different. Okay, it is not out of this world. It means the black hole purely follows the law of gravity, and it is same as any other objects in this universe. Okay, so that is my last point. Yeah.
Sounds great. Thank you.
Yeah.
Go back to here we go. All right. Let me see some questions. Is time the measurement of the movement of matter?
The motion of matter, right? Time is a parameter in our physics equations, and so you can look with respect to this parameter how things are changing, but that's not an explanation as to what time actually is.
Right.
So in relativity, time is constrained. The measurements of time are constrained. They depend on the observer. But what time actually is doesn't emerge. What is time actually? That's not something that's still discussed.
Gotcha. Okay, let's see. Yeah, it's definitely hard for me to kind of wrap my head around some of these things, like to view time and space in these counterintuitive ways is definitely gonna.
Yeah, I mean, I think the message is that when you look at the world, I mean, so even the world of a black hole isn't the real world, because the real world has all sorts of objects and they're all warping space. The Earth does the same thing. The black hole is just sort of the extreme of that.
Right.
And so, can you recover a notion of a unique present and claiming that that's what involves all of the things that are real? And the answer, I think, is clearly a no.
Okay.
I'm arguing that you can see it even at the level of special relativity, and when you add the things that curve space and time, that gets only worse, and the worst situation is when you have black holes.
Now, the evidence for all this goes beyond pure mathematics, right? Like we have more concrete observations as well.
Yeah, of course. Actually, I would like to mention that when we study black holes, it is the most interesting object for us, because it is the simplest object, because we just need to study only two properties of black holes, the mass and the spin, and that is enough to explain everything that can happen around it. Okay.
Gotcha.
So, and also I would like to mention that in recent time there have been several new interesting results related to black holes, whether it is about gravitational wave detection, because the gravitational wave, means in a way you can say the ripple in space-time, yes? Because of this, there are some kind of mergers of these compact objects, like neutron star merging with each other, or neutron star black hole merging with each other, or black hole merger. So in last few years there have been quite strong evidences of how these detections are possible, and because of further improvement in instrumentation. And also last year the Nobel Prize was given for studying the compact object in the center of our galaxy, yes, which is like few million solar mass, and the Nobel Prize was awarded for that work. And also there is a project called Event Horizon Telescope Collaboration, where they claim that they could see the actual black hole shadow, and especially the last orbit of the photon around black hole, which helped them to determine the mass of the black hole in another galaxy, and which is like some billion solar masses.
So I don't know if you've heard of this, Cease, but this is now about 2 years old. They pointed these radio telescopes that are all over the Earth at this object 53 million light years away from us, which means that the light that the telescopes received took 53 million years. And we have all sorts of indirect measurements that this must be a 6 billion solar mass black hole there. We see this enormous amount of energy coming from this object. And we pointed a telescope there, and we were able to resolve the region where, according to theory, we should be able to see the black sphere. And
right. Go ahead.
And for the interest of the audience, I would like to mention that there is a special issue published by Scientific American in this year. It is about the golden age of black holes. So you can find all possible interesting articles on recent development related to black holes in this special edition of Scientific American. It is not an advertisement, but it was issued in May 2021, and in general the community is accepting that, okay, this is really a golden age of black holes, where we are our technological advancement is helping us to understand this universe in a much better way than before.
I do need to show this comment because it amuses me. Otangelo, with his usual rejection of evidence and science and reality, says the principle of cause and effect is the most universal and has never been broken. And for that,
nothing we said, we explicitly pointed out how the events that are causally related in space-time are obeyed by all observers. We didn't flip cause and effect relationships. So that comment is not relevant to today's
presentation. Also, I would like to add that for material bodies there is a certain limit of speed. Yeah? So the maximum speed we can attain is the speed of light. Yeah? So in that sense, if as long as you are in this universe and you are not allowed to exceed the speed of light, this cause and effect is a universal property. But maybe in parallel universe, there is a possibility that objects are moving faster than the speed of light. Then there can be reversal of this role also. So like that means the effect will be happen before the cause.
But right, so going back to also previous conversations that we've had with you, David, you want to say that causality is emergent, not fundamental. So, for someone to come in and state it as, no, it's a real thing.
Well, it is a real thing. I mean, the fact that it's emergent.
Well, the emergence is real. The emergence is real, but it's not, like you said, it's not that the cause is always the cause and the effect is always the effect.
Well,
you can reverse
from an emergent perspective, then you would say this thing caused that thing. That's perfectly fine. But when you're looking deeper,
no, as long as you follow the traffic rules of our universe, okay.
Right, but the point I'm making is that
within the speed of light.
Right, but the point that I'm making is that when we do look at things deeper on a deeper level, we're talking about what is real. We have to look at a deeper level. Yes, we can talk about emergence. We can talk about how to structure the conversation. But for anybody to say that causes are always causes and effects are always effects, for example, like this comment, right? And I'm not going to spend too much time on this, but it does amuse me. Because something has always been, and since that is not the universe, it is God. Those kind of leaps.
Look, talking about God, you don't need to look for answers then. You already have the answer. Yes.
Right, exactly.
So, means our whole objective of spending this career in science is finding answers to unknowns. Yes. If you assume God, you don't need to find an answer to anything.
And,
we have that answer for everything.
Otangelo's body of evidence is a message board of misquotes that he's copied and pasted into like a pseudo document. That then he says, "Look at what all these scientists are saying, none of which are actually saying what he thinks they're saying." But it does entertain me on occasion.
No, and also I would like to point out, as I mentioned in the beginning, that there is a big difference between a scientific intuition and a fantasy. Fantasy can take you anywhere.
Right.
But scientific intuition is based on the whole progress of this knowledge in last some 100 years, and we build on that. We are building our knowledge on the shoulders of giants who were before us, and they knew how to look at this universe, and actually people were even punished for thinking in a critical way or in a scientific way.
And this is a good example, like, of why I think that in many ways the scientific approach and the religious approach are in conflict. Because here, on the science perspective, we have intuitions that we are finding out fall short of matching with the observed reality. And so we are trying to be intellectually honest and to kind of reframe our understanding and to move around what it is that we're actually observing. On the other hand, on the religious side, you have people who, based on nothing but assertions and nothing but their intuitions and nothing but their wishful thinking, make claims like the ones that we're seeing in the comment section, claims about energy, claims about potency, claims about cause and effect, stated as fact without the actual methodology to back any of those things up. And I always find the contrast between the religious mindset and the scientific mindset to be fascinating to me, which is why I think it's amusing when atheists or non-believers are called arrogant, when I think it's really the other way around. We're trying to be as honest with the tools that we have available. Tanya, the fact Newton was a scientist is irrelevant. People can have contradictory beliefs, and he did. So,
and also, I would like to say that in science, we always have the opportunity to question.
Sure.
But in religious things, you write one text several hundred years ago, and people just read again and again without questioning it. So it is.
And if there was evidence for this God of his, then science would have something to say about it. It's not in principle against anything being the case. But when you lack the evidence and you just make statements out of nowhere because you can't imagine things being different, it just is what it is.
It's what surprises me is that when the skepticism, the criticisms that I hear about the discussion that we're having tonight, I mean, that suggests that we're looking at nature and we're just pretending that things are there that we're not really finding. I don't understand. Isn't that the implication of these criticisms, that we're just inventing reality? We're not really finding these things, and we're just inventing this stuff.
It's a lack of willingness to actually engage with the world. For example, like this comment, he says, once you remove God as the cause of physical reality, what mechanism is left to explain our existence? None. You're ignoring the totality of science and philosophy by making that kind of claim. Yeah. First of all, you have to explain how something non-physical can give rise to something physical, which is the mind-body problem. And newsflash, you're not going to be able to answer that question. The fact that you can't imagine something else bringing physical reality into existence, if that framing even makes sense, is
you're bringing physical reality into existence.
Yeah, like even framing it that way, just failing to understand what's actually being said here. So no one said removing God as a possible explanation. We're fine with God as a possible explanation if you have evidence for that claim, not just your incredulity.
You're seeing comments, but I don't see any comments. I don't think we're not seeing any comments.
Yeah, I have questions. Are you reading comments?
Yeah, he's reading comments. But
yeah, so from my sorry about that. Yeah,
I'm getting confused now.
Yeah, so from my screen, I can see the comments that are going on the YouTube channel. But
so like putting the comments on.
Yeah. So for example, here.
Maybe you can read name of someone.
Chandra said science has discovered a universe had a beginning, therefore a cause. This is just.
But all of those things are wrong.
Right, all of those things are wrong, and this is what I'm pointing to, like the arrogance of theists making those kind of claims when they just don't know what the science is saying.
Look, I know. Also, I would like to invite them to read a bit so that they can enjoy what we enjoy.
Sure, right. Yeah.
So the thing is, like, if you want to really criticize something, you need to work on it. Yes, you need to read those things. Yeah. Right. Then you criticize. Then we enjoy this. Yeah. Okay, you have done some homework on it.
But you know what it is that a lot of these people, even when they try to read some of these things, will derive what they want out of what they're reading. Like the amount of times that I've seen people use sources that actually state the opposite of what it is they believe, and just not be able to connect the two. Like we've had Chandra on our show once before, and I mean Mike, who he's not here with us tonight, completely exposed his scientific misconceptions all the way through, and yet he was still trying to quote scientists who don't actually agree with the things he's saying. It's it's what wishful thinking does to the mind. But anyway, really interesting stuff. I'm glad that you guys brought these things to me that I could share with the audience.
Yeah, thanks for having us. It's always nice to
So
describe
is there any question with respect to today's discussion? Like we went to God and science.
We went directly to God.
We went to the supreme question,
If anybody has a question before we close up here, feel free to post it in the chat. In the meantime,
relativity and presentism and black holes, which we really talked today.
This is what we actually talked about.
Yeah.
Zachariah asks a quick question before you go. Yeah, I'll post it as well. Does a spinning black hole have a larger or smaller event horizon than a static black hole?
Yeah. So in case of a spinning black hole, so first of all, the spinning has two things. One is the magnitude, and another is the orientation. Okay. So when we said about the orientation, that means there are matter falling onto the black hole. Suppose I'm not talking about isolated black hole, but a black hole with a companion which is giving it a matter from around. So suppose in case of our galactic center, so there are stars which are releasing wind from its surface, and those wind material are getting falling towards this center of the galaxy, and which has black hole. So in that case, what happens is when the spin orientation of the black hole is same as the matter which is falling onto it, then this event horizon has a size which is smaller than the static one. Okay. However, if the spin orientation of the black hole is in opposite sense with respect to the accreting matter, then the event horizon is bigger than this static black hole or non-rotating black hole. So David, do you want to add anything?
So Chandra is describing basically the kinds of things that we explore, which is stuff falling onto rotating black holes.
Right.
And that's really what black hole astrophysics is about. Most objects rotate, right? The Earth is rotating, the sun rotates. Most objects in the universe rotate, and when they form black holes, you expect to get rotating black holes. And they're interesting in and of themselves, but what we do is try to understand how to explain the enormous amounts of energies that we see coming from the centers of galaxies as the result of gas, dust, and stars falling into rotating black holes. That's really the subject of our research.
Sorry, I realized I did a mistake. Sorry, because we have different radius. So okay, so in case of event horizon, the bottom line is the spinning black hole has a event horizon smaller than the static one. So let us remove this thing of orientation, because this orientation has something to do with the things outside the black hole horizon. So those are different radius, because I imagine something else. So sorry for that. So the thing is, the spinning black hole has a smaller event horizon than static black hole. So that is the.
Gotcha.
And just to give people a sense of how complicated solving what space-time is like near objects, right? So Chandra at the beginning of the discussion was talking about static black holes. These were discovered by one person playing around with math in 1915. The spinning black hole is much more complicated, even though it's much simpler than other kinds of space and time, more realistic space times. The spinning black hole took it wasn't discovered. The way space and time changes as a result of a spinning black hole wasn't discovered. That wasn't solved from the Einstein equations until 1963, 64, I think. Maybe it was 65.
Yeah, so 63, I guess. That's very much. Yeah.
Gotcha.
And any other more realistic space-time requires
So actually, there was a
computers to solve.
huge time gap between because when you talk about these black holes, we are talking about the solution of Einstein field equations, and so for the non-static case, for the static case or the non-rotating case, the solution was given just few years after the Einstein proposed his general theory, like in 1917. Somebody fighting in the First World War sent him the solution from the battlefield. Okay, so that was for this non-rotating black hole.
1915, in the fall of 15,
Yeah.
Einstein published his equations.
Yes,
It was in the
yes,
spring of 16 that Schwarzschild solved the equations.
yeah. So quite close by that, the solution of non-rotating black hole. While rotating black hole solution came, like as you can imagine, it came after like such a long time, more than 50 years, by a mathematician in New Zealand. Actually, he was working in Britain, I guess. His name is Roy Kerr, and so yeah, there is a difference of event horizon size.
So, are there any other questions from the audience you guys want to ask? I do have one question before we go, but I want to see if anybody else had anything else that they want to answer. Doesn't look like it at the moment. Well, if anybody does come up with something in the next few minutes, let me know. But I know this wasn't the exact topic for tonight, but I did want to ask either of you about this notion of fine-tuning. David, we've talked about it before, why it is that you think that the fine-tuning argument isn't actually a good argument for the case of theism.
Well, I agree that it's the kinds of structures that you would have in the universe would be very different or non-existent if you change these parameters.
Sure.
So in that sense, there's something that needs to be explained. But if you want to talk about surprising configurations of matter and energy, there are places where, in the fine-tuning argument, it's hard to really get a sense of how fine-tuned they are. But there are other places in physics where you can calculate exactly how unlikely the actual universe is in its configuration of matter and energy, given what we understand about the laws.
Sure.
And so, in other words, there is that kind of question in other parts of science and other parts of physics, but you would never explore that in terms of, you never say, oh, it's all that's the way the universe is. It's extremely special and unlikely in order for human beings to exist, because you don't need that unlikeliness, that specialness, the way matter and energy are the configuration of matter and energy in the actual universe for humans to exist. So we see all that. We see those extremely unlikely states that need explanations, but they're unrelated to the existence of human beings. And so that problem exists. That question, unresolved questions, pressing questions exist. And the question is, how are you going to answer them? Why appeal to a fine tuner? You wouldn't do it in situations where we have a much greater handle on the surprising features of the universe. Why do you then allow yourself to do that in a realm that we understand even less? I think that the fine-tuning of the constant is something we don't really understand very well.
And I guess the thing is, why assume that the fact that the constants are what they are had to be put in place? Like what? Yeah, you get unlikely events.
Yes, we would like to explain why these things are what they are. I'm not a fan of anthropic arguments. I'm always hoping they're going to come from somewhere. Right?
Yeah, well, I guess what I'm
Chandra,
saying
I
is
don't know.
that,
What do you think?
Well, means I'm trying to understand what is really meant by fine tuning. In which context you mean to say?
Like, if you change the constants of nature by a little bit, then stars wouldn't form. You wouldn't get galaxies. Okay. You would get the universe would just expand. If you changed dark energy, then a little bit you would get a completely different universe.
Yeah, means the actually in science we have possibilities are infinite. But anyway, so our goal is always to find how it happens rather than why it happens. So you can think about infinite possibilities, but our main objective is to find, I mean, how it is like. How means and what are the things responsible for how it is seen and the things we observe. So that is our goal. So we are not trying to create our own universe. Rather, we are trying to understand the universe we observe. So,
Yeah, and it's an assumption to say that a fine tuner is the only rational explanation. And there's no reason to think that that's the case.
It's also it's not science, to say something like that. Scientific idea needs to do work. It needs to predict something. Science can come up with patterns. When you don't understand something, to say, oh, that's just because there's some intelligence behind that doesn't do any work, doesn't do any scientific work. So
Right.
I'm not sure why people think that it's a good idea to invoke those kinds of explanations.
Because they're trying to justify their delusions, and they try to use scientific observations like, if you change the constants, we live in a different universe.
There's definitely something there that we want to explain,
yeah.
and understand, but don't.
No, I think our objective should be first to understand this universe rather than other universes.
Right.
So we still don't have full understanding. We are still on the way of
Yeah,
even
some
this
people
universe.
would say that in order to understand this universe, you have to understand all the universes.
Yeah.
Right? I'm not a big fan of that, but.
And the other thing that I've noticed is that on the other
there
side,
might be a universe where people might be walking on their hand rather than legs. So there can be many possibilities.
To acknowledge a lack of answer, like to say that we don't know yet, is more honest and a better answer than to pretend like you have an answer based on nothing but your own wishful thinking. So that is why what science does is always going to be actual work to be respected and superior work to just the fantasy of people that want the world to be a certain way.
Scientific idea has to do some work. It has to make money, so to speak.
Right. Well, okay. If there's nothing else that you guys want to add,
thank you again for having us.
Thank you, guys. I hope Chandra, you should come back soon, and both of you.
Yeah, thanks.
I'm getting ready to go to bed. Chandra's getting ready to go to work.
Right.
Opposite sides of the world. So.
Gotcha. Well, yeah. Thanks again, and we'll have to do this again soon.
Yeah, sure.
Thank you.
David, I'll give you a call.
Okay.
All right, guys. I'll address one last comment. It's not. I never said it necessarily has to be a naturalistic explanation, or it's not materialism of the gaps. It's we don't know until we have all the information. It's you who applies gods of the gaps anytime that you don't already have a full answer. But again, it's a typical example of projection that you're engaging with here, and it's apparent to everybody that engages with the type of things that you say. Anyway, having said all that, this Friday, 8 p.m., I will be hosting or co-hosting Truth Wanted, doing my first call-in show. So that will be an interesting time. Thank you, as always, for anybody that supports us. Please like and subscribe to our channel. Our Patreon is patreon.com/axiomsontrial. If you would like to subscribe on that as well. Yeah, so I guess that's it. And we'll come back probably sometime this weekend Monday at the latest, but I'm guessing probably Saturday. We'll be doing something else. So thanks as always. I hope you guys enjoy this content, and I hope everybody's doing well. And have a good night, guys.